This jump tutorial will demonstrate how to conduct paired analysis in jump for means, and the data set that we're going to be using here is displaying the freshman 15. It's a larger data set than what we discussed in class, and it's from the Triola textbook, but it's the same. We have an initial weight in September for these students, and we have a post school year weight in April. And we have two weights from the same individual. So we don't have these independent data points anymore, so we have to take the difference and then conduct one sample analysis on that. Now there are two ways to do this in jump, and I'm going to show you the harder of the two first, but it's used more of the time, or more generally useful. So how we can do this is just like we did in class. We first need to find the differences between every single data point. And in jump we do this by defining a new column. So we come up here in the toolbar to the columns option and we click on new column. Now I'm going to just type in diff here for the label, and we want to go to column properties and then click on formula. What we're going to do is we're going to specify what difference we want. So I'm going to do a post minus pre, so if students are gaining weight, it'll be a positive weight. So I click on the weight in April, then I click on the subtraction sign, and I click on weight in September. So it's defined my difference, and then I go and press OK. Now in the background there you can see it's already calculated some differences. If we hit OK, it will save those. Now what we do is just like we did for the one sample t-test, we come up to Analyze, Distribution. We click on that and we go down to our difference and slot that in for the y variable and then press OK. Again, I always like to stack the output. So in order to get confidence intervals for this, we see that we already have the mean confidence interval here. But if we wanted a different level, we could come down here to confidence intervals again, next to using the red option tab next to diff. And let's say we wanted a 98, we go to 0.98, we can click OK, and we can keep on going from there. In order to get a hypothesis test, we go down to test the mean again, and we specify hypothesized mean. In class we used 15, and we did not know the true standard deviation here, so we leave that blank. You can see again that we have the output for our mean test here, and we're also given a graph illustrating the p-values. So you've already gone over what the output of this test is, test statistic, p-values, and all of that. So that is one way to get all of this output. So I'm going to close this down now and show you the other way. The other way only tests if the mean difference is equal to 0 or against one of the other alternatives, I guess. So we couldn't do what we did this time and say, okay, let's assume that the difference is equal to 15. So if we wanted to test whether or not there was a difference, we would go to Analyze. We could go down here to this Matched Pairs option, and then we have to select both variables of interest in this paired response column or entry. And then we click OK, and then we're given all of the output we would need. We're given our confidence interval here, we're given the mean difference, we're given our t-ratio and the degrees of freedom used and the p-values, and we can come up here to options and we can change the alpha of our test if we wish. So if instead of a alpha at 0.05 we wanted 0.1, we could do that, and notice that the confidence interval changed, and that was all. So really, conducting the paired t-test in jump is really similar to the one sample situation with a few differences. So remember, the easiest way is if you're testing just for a difference, so mu sub d equal to 0, we can use the matched pairs option. Otherwise, we have to define a new column with these differences. Let me close this down so I can show you. We have to define these differences again and then run a one sample t-test.